Okay, welcome to the next video of our first-person narrative tutorial. Last time we went over creating an inventory and a key inventory object. In this episode we are going to cover customizing the door so that it works with these key inventory objects. Alright, so I think here's our door, here's our key. We need a way for the designer here to sort of say, all right, yeah, this is a locked door, but it will be opened with this key. And so we got to figure out a good way, a good way to implement that in code, and B, a reasonable way to make it easy to set up for designers so that they can make the game quickly without sort of stumbling through this awkward, complicated setup. So there are a lot of ways we could approach that question. But I think, let me just give you an example. What if I made a serialized field here and it was just a string and it said type, you were supposed to type in, as a designer, you're typing in the name of the key that we're going to look in the player's inventory for. And if they have that key, that's what's going to open the door. Well, the problem with that is, what if the player types it wrong? They could type it wrong here, or they could type it wrong here, right? So that's easy to mess up. So I don't like that plan. Instead, what I'm going to do is, why don't we add a serialized field to the door script that is of the type inventory object, where you can just actually drag or select from a list the very instance of an inventory object that you want to use as the key. And then that way it'll be pretty clear and difficult to screw up. So let's try that out really quick and see what it looks like. So I'm going to go to my door, and up at the top where we are going to add a new serialized field, we will, so this is interesting. I guess I'll add it like at the very beginning, and then we can talk about this locked field next. So this is going to be a serialized field, and it's going to be a private inventory object. So the only thing you can put into this field is an inventory object, and we're going to call it key. And again, the idea is that, well, let's just save it and see what that did. If I save and go back and look at the editor and click on my door, it's going to take a sec to compile, and I'm just going to minimize or collapse this components so that we can kind of quickly see the door script. Now we have this thing for a key, right? I'm going to suggest that, well, first of all, let's rename this inventory object to key, and then, we can even call it yellow key because that's what I called it earlier. And let's say that this key is for this door. So how do I do that? I just drag the key into this slot for a key, and then if I forget what's what, I can just click here and you can see it's highlighting it for me, right? I can double click it and it will select it for me. I have an idea about how to simplify this setup. So right now the player has to click that it's locked and drag in a key. But I kind of think that if there's a key, that means there's no point of having a key unless the door's locked. So maybe we can actually hide this from the designer and just say that if the designer plugs in a key, it's going to lock the door, to kind of reduce the number of steps the setup takes. So let's kind of look at how that would work. First, let's have a tooltip for the key, because that's going to be vital to communicating how this works. So we're going to say something like, assigning a key here will lock the door. If the player has the key in their inventory, they can open the locked door. We can say this door or whatever. Anyway, so that hopefully communicates our intent here. Meanwhile, I don't think we need this so much anymore. I'm gonna keep this is locked variable, I think, but I'm not going to make it a serialized field. So we'll get rid of this because I don't want to, I don't. What if the designer puts a key in but doesn't lock the door, right? It gets giving them more chances to mess up, and so we don't want to do that. So I'm actually gonna cut this line, and I'm gonna move it down to where my regular old fields are, not the serialized fields, which are normally at the top of the script. These regular fields down here are after the serialized fields and after the properties. So I have is locked right here. And let's see. Basically, I want is locked to be dependent on the value of this key. So in other words, if a designer assigns a key, is locked will be true. Otherwise, it's false. I could make this a property and inside of the getter put that logic that I just explained. If the key is there, then it's locked. But that's actually not quite what I need to do because what if the player picks up the key? Then it's like we need a way to unlock the door. There's at some point, even though there is a key associated with the door, is locked will need to be false because the door is not going to be locked forever. So I don't want whether or not a key exists to continuously define whether or not is locked is true. I just need that to initialize the value of whether is locked is true or false. So what I'm going to do is, I guess we're initializing stuff here. I'm going to make a little function. Well, I'll just type it in first of all, and then I'll make it its own function to make it more clear. So what do I want to have happen as soon as the game starts? I want to say if key is not equal to null. So in other words, if the designer has assigned a key, is locked equals true. All right. So I only want to do this at the beginning of the game. And just to clarify this, I'm going to select these lines and hit Control period, and then choose Extract Method. And I'm going to rename this to Initialize is locked. Just to be, giving this a name helps express its intent. So we're just going to initialize is locked as soon as the level starts. Okay. So that takes care of that. The next question, I suppose, is how do we know if the player has the key, right? So if we go back down into the interact with method here, which is what happens when the player clicks on the door. Right now, if it's locked, it never opens, right? We only do the stuff involved with opening the door if it's not locked. So we need to add to this a possibility for what to do if the door is locked. And inside of that, we need to check if the player has the key and then do something special. So how do we know if the player has the key? I'm going to make a property for checking if the player has the key. So I think we'll put the property right here, I suppose. So we'll say private, it's going to be a bool, and it's going to be called has key. Now normally we're used to making properties public, and that's kind of like their whole point is to make a variable public. But in this case, I don't think anyone besides the door needs to know whether or not the player has the key. And I think just the way, this bool is completely dependent on one little piece of logic. So I think it makes sense to use a property here so we can sort of, we can link the value of has key to this other piece of logic that I'm about to write. So let's see. So this is going to be a read-only property. So we'll use this lambda syntax because that's the fastest way to do it. And every time you access has key, we're actually just going to check one thing. And that is going to be, does the player inventory objects list contain the key? So I think we can just do it like that. So in other words, what we're doing with this property is just making a nice, easier to read name for this. So has key is just totally based on whether or not this inventory objects list contains the key. So you can see that, while it may not immediately be clear why properties are useful, they're great for things like this, where we want the value of this sort of fake variable. It looks like a variable, I can use it like a variable, but really it's just returning the value of some other logic like this one. So list.contain, it's just going to check if this thing is in the list, and you can read more about it. It's in the notes. You can see here's list.contains if you want to see the details. Okay, so now we have a bool to tell us whether or not the player has the key. So let's go revisit this method and figure out what to do when the player has the key. So I think we're going to need to refactor this logic a little bit now that we can support cases where the player has the key, because basically what's going to happen when the player has the key is going to be pretty similar to what happens if it's not locked. So I'm going to express this all a little bit differently, basically. So we're going to say, first of all, we're going to keep this, because if it's already open, the way our game works, if the door's open, we just can never use it again. So if we're only going to do any of this stuff if the door is not open, so that part's good. But next, I'm going to kind of start rewriting it. So let's just don't worry about this. I'm going to leave it here as a reference, but I'm going to kind of rewrite it. So if the door is not open, first thing I want to know is if the door is locked, and the player does not have the key, right? So if the door is locked and the player does not have the key, what should happen? Well, basically this. That's what this was doing before. So let's just copy this line and put it in here. So we're not going to open the door. If you try to interact with the locked door and you don't have the key, we're just going to play the locked sound effect, right? Next, what do we do if it's either not locked or it is locked and we do have the key, right? So that's what this else will be. So else, and we can add a comment to make this more easier to follow. So if it's not locked, or if it's locked and we have the key, that's what's going to happen in here. And that is going to be all this stuff, I think, right? So we'll put that right here. So we're going to play the open audio clip. We're going to tell the door to open. We're going to change the display text to be empty. And we're going to let the door know that it's open. So we can delete all the rest of this, but remember, it's very important that you keep this, because this is what's actually playing the sound effect. So I think this little addition to our logic is all it's going to take to dictate whether or not we can open a locked door based on if we have the right key. So let's go ahead and test it out. Let's save. Let's go back to our game. Make sure it compiles. And let's test some stuff. And we're going to actually, in this test, I think we're going to understand some next steps. So first of all, the door's locked. Let me just make sure, did I actually set, yeah, so I did actually set the key, I did associate it with this door. So if you haven't, make sure that you have actually assigned the key to the door, or your test won't work. Anyway, so the door's locked. I don't have the key. I'm going to go over here and take the key, and I should probably just make this say take key again, but whatever. So I'm taking question mark, question mark, question mark, which is actually the yellow key. And now I walk up to the door and it still says locked. Now this is, I think, a little problematic. The player is at this point trained to understand that if you click a door that says locked, it just shakes and doesn't open. So if I click this, it actually did open because I had the key. So my lock and key logic is working. Oh, and look, now the display text still says locked. The problem is I want to add a new state to my display text so that if the door is locked but I have the key, I want to say use the key. And then after that, once the door is opened, it should always just make the display text hide, because there's nothing I can ever do with this door again. Once it's open forever. So those are the two things on my list. I need to add a new message for what the door says if it's locked, but I also have the key, and I need to make sure that this display text goes away once the door is actually open. So let's look into accomplishing those things here. So let's scroll up in our door script and look for what we're doing with the display text. And you might remember we had the conditional operator here. We were being real fancy with this display text property, saying that if the door is locked, we're going to show the locked display text. But if the door is not locked, we're going to use the normal display text functionality. And that was great when we only had two states. But now we want to do a little bit more complicated stuff, like if it's locked and you have the key, we need to do something different. So I think basically we're going to kind of comment this one out and kind of revisit this longer syntax, because we need the full syntax to be able to express this more complicated logic. So I'm going to delete this comment and then sort of uncomment all of this out with this little nifty button. And so this is just, remember, our alternative way of expressing the same logic as this, but we need to extend it a little bit now. So first of all, what do I do if the door is locked? Well, if we only have one line of code under this, it's okay to not have curly brackets. So that's all right, I suppose. But what I need to change, I don't like how there's two ways this code can return. It's kind of bad practice to have multiple ways to exit your code. So I'm going to try and refactor this a little bit to make it easier to read. So I'm going to make a string local variable called toReturn. It's a local variable because it's only used in this small context. It only lives in here. You cannot access this anywhere else. And rather than returning right away if the door is locked, I'm just going to change the value of this toReturn string. So I'm going to say toReturn equals that. Then same thing here, I'm going to say toReturn equals that. And then at the end of it all, I'm going to say return toReturn. And that way we now only have one way to exit our code. So it's just easier, when this is maybe this is easy to follow because it's so short. But if you have a longer function, it can get tricky to track down exactly the different ways you can exit out of the method. So it's much better to always have a single point of exit. Or if you're going to have multiple ways to exit your method, make sure you document it so it's super clear. But I think we can just sidestep the problem here and only return once and just change the value of this variable based on what we need it to do. Alright, so if it's locked, we're going to set the display text equal to the locked display text, but we need to actually make this more complicated now, because we need to cover what happens if it's locked and you have the key. So in other words, it sounds like we need the value of this to be based on a condition, which means maybe we want to revisit this conditional operator. So we'll say, what's the condition that we're interested in using to govern how we assign this? It's going to be, do we have the key or not? So has key, question mark. All right, if we do have the key, what do we want the value to be? We want to use some new display text, basically. So I think we can write that text right now. We'll say, I'm going to use an interpolated string. I'm going to say use, and then I'm going to type in the name of the key, which would be key dot, not game object. The key should have a name. So maybe the name is not something I can access here. Let's take a peek at it. So inventory object has an object name, but it's just a private field. So I need to make, if I want to be able to access this in another class, I need to make a property, a public property that can map to this field. So I can do that right here. I will say public object name. This is a string. I have to say that it's a string. And then I'm just going to have it point to this thing. There we go. So now I can go back to my door, and in theory, key.objectName is a thing. So I want it to say, if you have the key, if the door's locked and you have the key, I want it to say use the key. And then the next question is, what do I want it to say if you don't have the key? So that is what will be on the right side of the colon. Remember, this question mark colon thing is the syntax for the conditional operator. If you need a refresher on it, check out the notes. I think it's in here somewhere. At least I thought so. Yeah, conditional operator right there. Anyhow, so if the door is locked and you have the key, we're going to say use the key. If the door is locked and you don't have the key, we're going to show the locked display text, which just says locked. Otherwise, meaning the door is not locked, we're just going to show the base display text, which I think works. So let's save this and kind of see where we got tackling our two issues we were trying to fix. So I'm going to run the game. Let's just take a look. It is locked. So it's showing the locked display text right now. Let's grab the key, and it says use the yellow key. Alright, so we fixed the first thing, which was make it clear that I'm going to use the key when I have the key and look at a locked door. The second problem was I need this text to go away now that I have already used the key and the door is no longer interactive. So let's take a look at what's going on there. So let's go look at the door code, and I'm looking at the interact function, and you can see this is kind of tricky the way we've got this set up, but basically, so if the door's not open, but it's either not locked or it's locked and you have the key, we're trying to set the display text to string.empty, and that worked fine for our doors that started unlocked. But now we have this problem where if we're dealing with a locked door and we have the key, we're still doing this, but it's somehow not working. So we're setting the display text to string.empty, but for some reason when I look at the door, it's still saying something different. So the lowercase d display text I know is set to string.empty, But remember, when you look at the door, you're actually looking at the property, which is the uppercase D display text. So this is what's ultimately determining the value of what happens in that display text, what I actually see there. And let's kind of go through this logic. So if the door is locked, it's going to return all of this stuff. So we're never actually going to show me the lowercase d display text unless the door is not locked. And so remember, we're initializing is locked based on if there's a key set. But if I were to look at this, if you right click on this and hit find all references, it'll show us every spot that we're ever using this value. So if is locked, okay, is locked equals true here. And here's another one, if it's locked and you don't have the key. So we can see there's one spot where we're setting this true, and there's never ever ever are we setting it false. So basically once this thing is set to true, there's nowhere ever it's getting set back to false, which means if we go reconsider this, once is locked is true, we're always going to be doing this. So the problem is we're never going into here, which will show us the correct display text, which would be string.empty. And so the way to fix it is basically we need to say the door is no longer locked once you use the key. So let's go back down into our interact with function here. This would be the situation where we are essentially using the key. So right here we can say that is locked equals false. Like once this door is open, is locked equals false. So let's try this. Let's save and see if that fixes the problem. I'll run the game as soon as it's done compiling. So it says locked. I grab the key. I look at it, it says use yellow key. And now it's not showing me any display text anymore. So problem solved. So that's cool. One last little bit of functionality I want to talk about. Another way to extend this. Some games, you might be familiar with these. Sometimes when you use a key, you need to use it again. Like you find a key that's useful for lots of things. Or maybe, we can think less literally. Like maybe the key is like actually like a key card, and it opens like all of the red doors, like in Doom or something. Or maybe it's a figurative key, like I don't know, you come up with some kind of like the door is locked, like the player refuses to open the door until you take their precious valuables, right? So the player has to click the precious valuables, picking them up, and then we can let them open this door, right? So that's one type of key, the key that's always going to be in the inventory forever. Other times there are in games like single-use keys, like once you find this key, you use it one time, and then just to keep your inventory streamlined, we just remove the key from the inventory because you're never going to need it again, and we don't want to confuse the player into thinking, have I used this already? Do I need to save it? What do I need this for? And so that's just more of a consumable type of a key. Or if you wanted, I guess you could make a game like if you remember the early Zelda games, their keys are kind of just generic, and you can use a key on any door, but they're consumable. So that would be another thing. I don't want to. You could make that a special feature and extend this functionality to make generic keys, but I'm not going to do that here. Instead, I want to show you how to make it so that once you use a key, it gets consumed and is no longer in the player's inventory. Which is not a problem now, I guess, because we don't even have a menu for it, but we're gonna. And so while we're sitting here looking at this code, let's go ahead and add that functionality. So up here in the doors, top of the door where we have the key and the lock text, I want to add one more thing. So right after the key, I'm going to have another serialized field. It's going to be a private bool, and I'm going to call it consumes key, meaning if you make this true, the key will be used up and removed from the inventory as soon as you use it. So I'll make a tooltip to sort of indicate that. I'll say, if this is checked, the associated key will be removed from the player's inventory when the door is unlocked. There we go. All right, so if you mark consumes key as true, we want to use up the key and remove it from the player's inventory once they use the key. So that moment where they're using the key is basically down here, right? So let's think about this. So basically, I don't want to try and remove a thing that doesn't exist, right? That could cause problems. Just trying to do anything with something that doesn't exist can give you a null reference exception. So I think we need to add a bit of a check to see if the key is null. So we'll say if key is not equal to null. Actually, we can make this kind of a compound condition. So if the key is not null and consumes key is true, right? So if this is true, we're gonna do something. What do we want to do? Well, we need to remove the key from the inventory. So we're gonna say player inventory dot inventory objects dot remove key, which this will remove the key from the inventory. All right, so at this point, there's a handful of things here that are related to unlocking the door. So I'm going to just select these lines and hit Control period and extract this method and rename it unlock door, just to kind of give it a name and be more streamlined about it up here. All right, so it's good to name our code so we understand what its intent is. So let's save this and test it out. Now, because we don't actually have a menu yet, we're going to have to rely on our breakpoint. So make sure you have this breakpoint here right where we're adding the key to the inventory, I suppose. And then the next spot I want to have the breakpoint would be right here where we are unlocking the door. So I'll put it right there at the end of this function. So after we've done all this stuff, we'll stop here and check and see if the key got removed. So first time we're going to check is right after they add the door, or add the key rather. So actually I'm going to move the breakpoint down to the bottom so that we can check after this has already been executed and see if the key has actually been added. Second time I'm going to stop the game to check is where we're trying to remove the key from the player's inventory. So make sure you have everything saved. Let's go ahead and attach to Unity because we need to use the debugger here to test this. And then we'll go back to Unity. It'll compile. And I want to make sure that I understand how my door is set up. Actually, while I think about it, I'm going to change this take question mark to say take yellow key. And then I'm going to check the consumes key box. Remember, if I mouse over, I get my nifty tooltip. And so now the key should be removed from the inventory once I use it. So step one, make sure the door still works. It's locked, it's working. Let's grab the key. So I'm going to take the yellow key, hit my breakpoint. So I hit my breakpoint. Let's take a look at inventory objects. I move my mouse cursor over it. There's one thing in it, and it should tell me what it is, I think, right? I thought, yeah. So the object in index 0, which is the first spot in the list, is the yellow key. Cool. All right, so I know that worked. Let's hit continue. So we go back to playing our game. Let's try to open the door. So this should use the yellow key, and because consume key is checked, it should actually take it out of our inventory. So let's see if that works. Hit the second breakpoint. So let's mouse over this, and we can see it says the count is now 0. So the key is gone. So it appears to be working. So I can continue, and the door is open. All right, so that's it. That's our key. We should be able to use this functionality to create a whole lot of different gameplay. It's probably a good idea at this point, since we're done kind of fiddling with our door. I would say maybe create the most default door you can. So really what I would do is maybe reset the door so that it's just in its generic form. Oh, except I didn't want to get rid of my locked audio and open audio, so I have to set that back in there really quick. Here's the locked audio clip. Here's the open audio clip. And I'm going to make my door a prefab. So rather than call this door frame, I'm going to call it swinging door. And I'm going to go ahead and drag it into my prefabs folder. So now I can make doors all over the place anytime I want. And this one is an inventory object, so I'm going to go ahead and reset it also. So it says take inventory object and inventory object, and I'm going to rename it back to inventory object. And I'm going to make this thing a prefab also. And we're not totally done with the inventory object, but we're done enough for now until we have a UI, because one day I want to actually like add notes and stuff. So if you want to place inventory objects at this point, like with the idea that this will be a note the player picks up, or a picture, or anything you want the player to have in their inventory to help them, like a clue, you can start placing them now, and we will go over how to add the rest of that functionality. Also, don't forget, if I have a cool model, something I found, like a piece of paper or whatever, I'm just going to pretend that this cylinder is my cool model. If this is a custom thing and I want to make it an inventory object or an interactive object or anything, I can just add that script and that'll work. So here we go. You don't have to use whatever I made my prefab. You can totally replace the default mesh, right? I can just replace the mesh, and that's fine. Or just put the script on a new mesh. All right, anyhow, this should be a lot to start making your game finally. And next we'll start talking about how to build the menu, the inventory menu.